Hello everyone, it's a pleasure for me to share our works. Our paper title is Research on Image Binary Classification based on Faster Style Transfer Data Enhancement. This paper proposes a faster style migration data enhancement method, which can quickly apply the still art of one image to another image without changing the high-level semantic content characteristics of the image. I will introduce our paper from the following 5 aspects. First is the introduction. For the massive images, it's difficult for people to quickly find the information they expect. This makes people urgently need a way to quickly and effectively obtain the required image content information from a large number of images. With the rapid development of image classification technology, convolution neural network has incomparable advantages in image processing based on convolution neural network has become the mainstream of research. Data enhancement refers to expanding the number of data sets to increase diversity in the training of convolutional neural networks. Some popular deep architectures, such as AlexNet, have millions of parameters, so it's necessary to train a fairly large dataset for a specific task, and lack of sufficient data will lead to overfitting. But collecting raw data is very time-consuming and expensive in many computer vision tasks. Still transfer is a neural network-based image still transfer method. The deep learning technique can be used to model the texture features and apply the artistic style of one image to the task of another. This paper proposes a data enhancement method based on rapid style transfer to expand data. Image convolution network and loss network are the parts of the faster style migration network. As shown in Figure 1, loss network is defined as feature loss and style loss to measure the gap between content and style. The depth of the network is an important factor in achieving efficient image recognition, but the deepening of the network will cause gradient explosion and gradient disappearance. In order to solve the above problems, this paper adopts the deep residual network as the backbone of the image convolution network. The deep residual network adds the residual module shown in Figure 2 to the traditional convolutional neural network, so that the output of the previous layer is directly input to the input of the next layer without convolution operation. The formula is the parameter weight of image convolution network. It completes the conversion of input image and output image and obtain loss function to measure the difference between the generated image of the output and the target image. For the loss network, this article defines two perceptual loss functions content loss fraction and still loss fraction, to measure the difference in content and still between two pictures, in order to ensure that this loss network has excellent interaction capabilities in terms of content and style. This paper uses the Fugang network model portrayed in ImageNet. The Fugang network structure is shown in Figure 3. Concerning the loss fraction, the first formula is the content loss fraction, which penalizes the content deviation between the generated image and the target image. The smaller the value of the loss fraction, the more similar the content of the images before and after processing, and vice versa. It is also hoped that the style loss will penalize the deviation in style, such as color, texture, and common margin. In order to achieve this effect, this paper proposes the following style reconstruction loss fraction as the second formula. Voicing the features of the portrayed Fugang network model will be of great help to the selection of the content and style extraction layer. The visualization of some features from the low level to the high level is shown in Figure 4. It can be seen that the low-level features extract simple directional edges and color features. As the layer deepens, the filter in the convolutional neural network becomes more complex, and the feature information that the filter can extract is also richer, such as features, leaves, eyes, and so on. In this paper, the higher layer is selected as the content extraction layer, and the lower layer are selected as the style extraction layer to train the style transfer model and combine the style transfer network to realize the image style transfer, as shown in Figure 5 and 6. From the results, when the high level is only selected as the content extraction layer, and the low layer is used as the style extraction layer, the migration result is completely pixelated. This is because too high a layer contains too much content information, and a too low layer filter almost only extracts some unimportant texture information. From the results, it can be seen that multiple consecutive layers from the low level to the high level are selected as the style extraction layer, and the layer closer to the model is selected as the content extraction layer can get the best migration effect. Through the experiment, it is found that the transfer time of different sets of the target image is often different. Use different style images to train a new style transfer model to continue the transfer, and make statistics on the transfer times as shown in Table 1. It can be seen that under the promise of the algorithm used in this article, the migration time of the target image has nothing to do with the style migration model, but only with the size of the target image. this paper, the original image dataset will be processed, and the main content features will be returned by using faster still migration technology. As verifies the effectiveness of the faster still migration data enhancement compared with the traditional method. Based on the provenance work, 5 still models have been trained in order to select a suitable still transfer model for data enhancement. This paper uses the class activation algorithm to measure the effectiveness of the transfer model for data enhancement. If the dataset used by the pre-training network is large and general enough, the spatial level of the features can effectively serve as a general visual world model. Figure 16 pre-training network is a convolutional neural network with 1,000 classes. In this paper, the improvement of Figure 16 pre-training network is shown in Figure 8. The convolution-based tree in the network is returned. All dense connection layers are deleted, and then a 2-layer disconnection layer and sigmoid activation function are added after the convolution base. The dataset used in this article is partial data of 2 categories of cats and dogs in the cargo dataset, with 5,000 images of cat and dog, respectively. The image data of cats and dogs are respectively enhanced by the traditional data enhancement method, selected at random, and the faster still transfer method proposed in this paper. The 2 expanded datasets are divided into train set, verification set, and test set. 2 expanded datasets are used to train on the improved Figure 16 pre-training network. The final train result data is shown in Table 2. From the statistical data in the above table, we can see that whether it is the traditional data enhancement method or the faster still transfer data enhancement method proposed in this article, the accuracy of classification prediction is relatively good, and both are above 85%. The faster still migration data enhancement method proposed in this paper is significantly better than the traditional data enhancement method, and the maximum increase is 5 percentage points. Based on the shortcomings of traditional data enhancement methods of diversified and single data after enhancement, this paper proposes a method of still transfer data enhancement to help convolutional neural networks in image classification. Firstly, a faster still transfer model is designed, which can transfer target images of different size in a few seconds to complete a specific still transfer. Secondly, this article uses the graded CEM algorithm to selected appropriate style transfer styles for different data sets, and then selects different data sets perform style transfer data enhancement. Finally, through experiments, it's found that the faster style transfer data enhancement method proposed here can help convolutional neural networks to classify images and improve the prediction accuracy of the model. The follow-up work of this article will focus on the study of more rapid and effective data enhancement method, and is committed to improving the accuracy of the classification model. Thanks for your listening.